Hey guys, how are you doing today? David here with Bright IoT. I hope you had like a fantastic 4th of July weekend. And today, as I'm traveling, here in Texas, I want to talk about like chain conveyors, and we have found like so the most common like example is like in the automotive industry, but also in the food and beverage, especially in the bakery industry. They have chain conveyors inside proofer box, and so we have dealt with this type of systems, and sometimes they're difficult if they're not designed correctly. They can give you like a lot of issues. Of course, motors are not the same, and chains can pull like on one side more than another, causing like they take up to tension too much and stop for a safety reason. And those applications, sometimes they're not set correctly, as far as like how the drives synchronize to each other. The most common like application have maybe multiple like gearboxes on different bays, just to pull the chain uniformly, and they have like they have one motor per bay, but sometimes we have found that they have two motors per bay, pulling the same gearbox, and that's getting even more difficult. Of course, the windings on each motor, even if you buy the same exact nameplate, they of course are different, and you can get like as close as possible if you buy like the same nameplate motors from the same patch, but even there are slight differences. So how we deal, and how to deal with this chain conveyor issues? Like I said, most common here is like not synchronized, uneven, and deal with also the mechanics, because when we deal and we also do like industrial automation, but most people don't realize that you need to take in consideration like the mechanical aspect, right? So in an application, of course, most of the people say, it's the automation, it's the common rhetoric, it's the program that is wrong, it's the setup that is wrong. But a lot of time, they don't take in consideration what is in the mechanics, how many gearbox, what like how many chains, transfer cases, and all of that good stuff, that we as system integrators and control guys, we are not really like the expert, but we are learning, and we learn how to take in consideration, how to study the mechanics of the equipment, right? So with that being said, again, with the chain conveyors, the issues again, they can fault, they can change the speed. One like drive can pull more than another. So how you deal with that? So first of all, you have to have a specific drives. If you buy a drive, you buy a drive off the shelf. You need to take in consideration if that drive can handle torque first. So regular drives, like out there, of course the most famous is PowerFlex 525, but we can use Altivar or Yaskawa, whatever is your choice. So small drives like that, they work 1 horse and even bigger, 5 horse, 10 horse. they mostly work, with current. So the equation that they use is, induction motor, velocity against hertz against frequency, and that's how they regulate, right? So and then you go like for stronger, tougher application. You may want like to use drives that allow to control the torque. So for example, now we have an application that we install like a PowerFlex 755, but again, no matter of the brand, they all pretty much work the same. So you need to enable like the torque function and use like a particular equation. Like when we go like to torque, we need to switch like the drive to vector mode, and then there are like different types of vectors, right? Modes. One that it calculates, the speed, the characteristics of the application based on the data you input and what is your reads from the application. Or the most precise is when you had like an encoder. But in any case, that's the way, when you have multiple motors tied to the same equipment, like in this case, with the chain conveyors. So there are different ways to set up. Of course you have like, if you have like one motor per bay, you're gonna use like master and follower, like a method. So basically, you switch all the drives. Let's say you have three drives, right? So you switch the three drives in vector mode, and then what you're gonna do, you take the first drive starting, from the beginning of the chain, and then you call that a master drive, right? So you need to send like a speed reference for them, like the same for all of them, of course, right? So when you've done that, so and then you take like the torque output from the master, and then you send to the follower drive, right? And then you will do the same with the second, let's say, drive or follower, and send his torque reference to the last drive. Let's say, in this example, we are using three drives. So what that does, allow to balance and load share across the board, like the load, right? Of course. So that's the most common method that is used in the chain conveyors. And then of course, in the case you have like two motors that pull in the same gearbox, you wanna do like there are again different methods. The easiest one is like we discussed earlier, one motor will be stronger than the other ones, right? So you will pull more amps. So the method you can use, let's say, you have like one drive driving two motors, and then you can split another second drive, and then do this load balancing by trimming the stronger one. So when you run like the application, for example, and then you look at your data, your amps that the drive is outputting, so you can see like the differences. So immediately, let's say the stronger runs like a 3 amps, and the weaker runs like 2.5, right? So there is a function in the drive that allows you to trim down the stronger, so you will balance the load across the same bay. And then of course you can get like advanced by doing like the master and follower technique, by using multiple drives. So there you can do a combination, you can do just one. Different ways are possible, but my goal is to inform you today and and let you know that if you're having issues with this, chain conveyors, just drop a comment, let us know, book a meeting in our website, www.brightIoT.com, and then you go to the contacts, and then you can find you can book directly there, just to discuss your application if you ever have any issues, and generally speaking, with drive issues, we can definitely help, and also with the new drives, I wanted to add this, you may thought during my video that you may need to add more wiring, add more cards, add more. So with the new drives, if you have pretty recent drive, we can do everything through Ethernet IP communication or any other protocol. So we can avoid also all the wiring, changing and all of that. Everything can be done. This load sharing or balancing, master follower technique inside the PLC, assuming that you have a PLC on that machine, which it probably is, and also the change in the parameters can be done inside the drive. Some drives also allow to do some logic too. So there are different options out there. So don't get scared. We also try to use what you have already. Not forcing you to buy new equipment. If it's not necessary. So anyway, so I want to drop there this these thoughts, and if you like the content, just thumbs up and subscribe, and let me know what you think. Have a great day, and God bless, and see you later. Bye.